The title of my presentation today is Capture Sand in Flocculated Fines, a new approach to optimize the capture of sand, oil sand fines in sand beach. It's a long title, and this is a typical research project midway through that we have to change the direction. So that's why it's the long title. So first of all, I would like to acknowledge my co-authors, Jamin Khan and Alessandro Gozal from Total E&P Canada. The outlines of my presentation covers background, objectives, experimental methods, materials, pilot flume test using MFT as fine source, conclusions, and future work. This project is motivated by AER Directive 74, which requires 50% of feed fines to be captured in the first placement in sand beach area, and deposits reach 5 kPa 1 year after deposition. So this is the phase 2 of the project, and during the phase 1 project, we found that the feed fines over fines plus water ratio is a key parameters controlled rate of fines capturing. So this project objective is to verify that the feed fines over fines plus water is a key parameter, because during the phase 1 project, we didn't have enough time to continue to have a thorough examination. So this, continue that to verify and also find its limit. Identify any other parameters which will be affecting the fines capturing process, and obtain more data on beach strength and dewatering capabilities. And for the dewatering capability part, it was conducted by UFA team, so I'm not reporting that part of the data today. And also develop a process so more fines can be captured. This is our apparatus. You can see this is a flume, 8 meter long, 1/4 meter wide, and 1/2 meter high. It's a rectangular, and the slope of the flume can be adjusted. And there's 2 gamma traversing densitometers, one at 2 meters from the inlet, and the other one is 6 meters away from the inlet. And so once the controlled feed loaded to the flume, it will set for 7 days consolidation duration. So the procedure is like this: you load the feed into the flume, and yesterday rather gave the presentation that the SRC method is contained because the limitation of our space and the apparatus. So the feed is contained in the flume for 1 hour. Then there's a wheel at the end of a flume over there. So after 1 hour, we lift the wheel so the free flow overflow can run off and to that tank here. So left the beach, settle for 7 days for consolidation. Okay, so this is the feed in the flume, and this is the wheel at the end of a flume. So we lift that plate 1 hour after we loaded discharged the feed to the flume. And after 7, we have the gamma scan or traversing scan 3 times. One is right after we loaded the flume, so it's a scan distribution of the feed. And then during the runoff, 1 hour after the deposition, we run another scan, and 7 days later we run another scan again. So there's 3 examination during the consolidation. And at the end of test, we have the field event test to examine the beach strength at 6 locations and 2 depths, so 12 points. And also we have a sample at 6 locations around the flume, and by sinking in a pipe to isolate, any water surrounding will not go to the well. And then we separate sample from the top of the lake, top of the beach, and the bottom ridge. So there will be 12 points of the sand, the concentration and sand fine ratio as well, alongside with the van test. So the material we use is a branded commercial Lake Mountain sand to simulate, because of the large amount of sand required, we didn't use the oil sand, but we simulate to simulate for the medium grade oil sand ore. And MFT used as a fine source was from Syncrude Aurora mine. And flocculant AF3338 was manufactured by SNF or provided by SNF. So I'm not going to go detail with this whole matrix, and which is available in the paper. And I just would like to have you to pay attention on two groups, distinct groups. This is a feed composition, and you notice that the feed fines over fines plus water ratio is up to like a 12%. So the fines capturing rate is stay above 50%, which is the directive 74 required. Once that ratio over to 15% or above, this fines capture rate will reduce below 50%. So right now you just look at this, and I will explain to you a little bit more later. And also the beach strength after 7 days has this data. And as you can see, once the other conditions constant, the feed concentration keep relatively constant, and once the feed fines plus over fines plus water ratio over 15%, not only the rate capture rate reduce, but also the beach strength reduce as well. And there's two more tests here, C number 8 and C number 10, and I will give you more information later. Okay, so here is an example when the feed fines over fines plus water ratio stay below 15%. And so this the dot here is the original level of the slurry. Then after 1 hour, we drain the free flow runoff, and then we have the gamma scan, perform a gamma scan 3 times, one for the slurry, one for 1 hour after the drain runoff, and 7 days later. And you can see this one, the runoff concentration is low at near like a 10% here. And this is the gamma scan for the slurry itself. So before the drain of the runoff, here's the runoff concentration here. And here is the solid concentration here. So this gamma scan is performed 7 days after the beach consolidate. And you can see there's a segregation, right? So you have the runoff lost. And the beach concentration, whatever stay on the beach, is pretty uniform concentration. And if we push this feed fines over fines plus water ratio to over 19%, and so after settle for 1 hour, open the gate, most of 70% of the volume is lost as a runoff, and only 27% of fines stay on the beach or captured in the sand. And you can see for the gamma performance, there's a gamma scan profile. The runoff is high concentration. Here it's all as a runoff, and the beach is stratified with it's layer by layer stratified. And after 7 days, there's very little left on the beach. So that's the feed fines over fines plus water ratio is the key parameter to control that process. Okay, so we see this distribution here, or the correlation here, and here is the feed fines over fines plus water ratio, and here is the rate of the fines captured in sand beach, and here is the critical value here, and over that value, now I show you the C2 over there and the C5. You see that once the feed fine over fine plus ratio over 15%, everything is a job, and so it's also correlated with the carrier yield stress. And because of time limitation, I'm not going to here, but written in the paper. Okay, so if we perform adding flocculate, before that is nothing flocculate, just a spark with MFT. And if we add flocculate 150 gram per ton of dosage, and we adding to the original, say, fines over fines plus water ratio below 15%, the concentration is still 55, nothing happened. It didn't happen because the component, when you flocculate the component, you need a population, you need an agglomeration. So if the population is low, this low dosage is not very effective, so it didn't change. However, if we increase the fines over fines plus water ratio, we increase to 15% and 16%, and the C number 8 and the C number 10 as shown, and the rate of fines capture rate is increased, and from 60% to nearly 80%. And why is that? We'll be showing in a minute. So flocculation at increase. Now, the C number 8 and the C number 10 not only increase the fines over fines plus water ratio, but also increase its total solids concentration. So as I explained before, the population, you needed the particle population to agglomerate. So for this one, although you have the same dosage, but because the particle population is not enough, so it didn't make any difference. And once you have the total solids concentration increase to 65%, and adding flocculant doesn't increase the rate of fines capturing. Okay, so let's see this C number 8 case. And the total solids concentration is 65%, and fines over fines plus water ratio 14%, and 100% gram per ton of the flocculant adding to the MFT, and it reached 83% fines capturing and 87% of volume captured. So if you can see this slurry, and the runoff concentration is very low at nearly 10%. Those are runoff, and also the runoff volume is very low. So you reach like 87% volume captured. So only 13% material lost as runoff. And also the beach concentration is pretty uniform. 7 days after settling, and so it's consolidation. And the concentration distribution is almost vertical. So if you look at this case of C number 10, and feed concentration is still the same, but we push the feed fines over fines plus water ratio to 16%, and so that's an increase, but we keep the dosage to fix. And so although the fines capture rate is still high, but it's reduced from the previous case, and as you can see, it's a start to show the stratification, and the concentration in the beach concentration distribution in the beach is slightly stratified. And also the beach strength reduced from 5 kPa to 2.6 kPa 7 days after deposition. Okay, as a conclusion, feed fines over fines plus water ratio is a key parameter which controls the rate of fines captured. Without flocculation, its critical value is between 12 to 14% to capture 50% or more feed fines. And the feed carrier yield stress is another key parameters, although I didn't explain here in the presentation, but it's in the paper. Flocculation pushes carrier yield stress even higher and retains the fines in the beach, so increase the rate of fines captured. However, beach strength is low. So a new approach is, instead of using sand to capture fines, I go the other way around, and you flocculate the fines, and adding sand to the flocculated fines to increase the strength of the deposit, and you achieve the high fines capture rate and high strength at the same time. So flocculated fines to maximize rate of fines captured, and adding sand to increase beach strength and prevent flocculated slurry from loss as runoff. Before, if you don't have enough strength or enough concentration, the runoff, although the feed is flocculate, but it will lose as runoff. And you adding sand into that flocculated layer, it will stay on the beach. So as you see, the C8 case shows like a feed total solid concentration 65, and you're adding 150 gram per ton to the total solids, and you reach 80% of fines captured 7 days after deposition. Yeah. And final conclusion is optimum flocculation dosage has to be developed based on the feed composition and to gain enough beach strength. So that has to tailor to each application case. And the future work, more work is required to study impact of flocculation on permeability, because as we know, in the flocculation is hinder the permeability, and so although you can capture more fines, but the volume is stay on the beach, is not gaining the water release. You know, it's a fight. You know, you have to. It's a fine balance. Large-scale field tests are required to develop a concept of using flocculated fines to maximize fines capture rate and adding sand to increase beach strength. And we will apply this approach to a flocculated MFT and of course tailings. So for that, Total is supporting us to have a new project here, and we designed and constructed a new flume, 15 meter long, 1.6 meter high, and 3/4 meter wide, equipped with pole pressure sensors and traversing horizontal and vertical traversing gamma densitometers. And so we will have a flocculated MFT coming, and coarse tailing is a core discharge. So, and this test is supposed to start in the new year. Okay, thank you very much for your attention.